All right, I'd like to talk about the next kinematic equation today. All right, so what variables do we have? In our equation, we've got four variables here. We have distance, we have final velocity, we have initial velocity, and finally, time. So those are our four variables from this equation. So the way algebra works, if I give you three of the variables, you should be able to solve for the other one, the fourth one. So let's just do a quick example where we can solve for distance. So let's say our final velocity is 30 meters per second. Our initial velocity, let's just make that 0 to make it easy. 0 meters per second. Oftentimes it will be 0. Oh, fire alarm. Okay, and let's say t is 10 seconds. Okay, and we want to solve for distance. So we can now just plug these values into our equation here. Distance equals 1/2 times VF. VF is 30 meters per second plus VI, which is 0, times 10 seconds. We can combine these terms. So now we've got equals 1/2 times 30 plus 0 is 30. So we've got 30 meters per second times 10 seconds. Okay, now let's multiply. One half, 30 meters per second times 10 seconds is equal to 300 what? Meters per second times seconds. What happens is your seconds will cancel out because you have seconds as a denominator and seconds as a numerator. So seconds cancel out and you're left with meters, which is what distance should be in. Meters. And now all we need to do is figure out what half of that is. Half of 300 is 150 meters. So for this example, distance was 150 meters. So if our initial velocity is 0, our final velocity is 30, and we know it took us 10 seconds, the distance we traveled was 150 meters. Okay, what if we're not solving for d? What if we're solving for one of the other variables? We have to rearrange the equation then. So this is where your algebra manipulation skills are needed. Okay, remember this is the same formula, just where instead of distance, it says delta x, which is still distance. Instead of 1/2, I just went ahead and it's this 1/2 of anything is the same as dividing anything by 2. So this equation hasn't changed, it's just written a different way. So say we're not solving for distance. What if we're solving for time? Now we have to So what if we're not solving for distance? What if we're solving for time? Now we have to rearrange this equation so t is isolated on one side of the equal sign by itself. So what does that look like? Okay, so first let's get rid of this 2. So to get rid of the 2, you got to multiply both sides by 2, right? Because 2 is on the denominator. If you multiply it by 2, the 2's actually cancel. So now you have so let's multiply both sides times 2. We'll cancel it out here. So let's just rewrite it. Now you have 2 delta x is equal to final velocity plus initial velocity times time. So remember your order of operations. You can't just multiply the VI times the T. The T has to distribute to both of these. But we're not worried about that. So now we need to get rid of this part, this VF plus VI, because we want to solve for T. So to get rid of this whole thing, since these 2 are multiplied together, VF plus VI multiplied by T, we can divide out this whole thing. VF plus VI. We have to do the same thing on the other side. VF plus VI. Okay. So now what cancels out? These whole terms cancel out. Now let's rewrite our equation. See, the only thing on this side of the equal sign is time. So let's put time on the left side now and just rewrite it. So we've got time is equal to 2 times our change in distance divided by the final velocity plus the initial velocity. So that's how you would rearrange the equation to solve for time. There's only 3 steps. Multiply by 2, divide by VF plus VI, and then you've rearranged your equation. The only way to get good at this is to practice, practice, practice. All right, let's do one more quick example of how to rearrange the equation to solve for a particular variable. Let's say this time I want to solve for final velocity. First, let's do the same steps we did last time in the beginning. We multiply by 2 on both sides to get rid of this 2 down here. So we're going to multiply both sides by 2. And that's going to cancel out the 2 on this side. Now you've got 2 delta y is equal to VF plus initial velocity times time. Okay. Now we want to get rid of the t. So we're going to divide both sides by t. And the t's will cancel out over here. All right, now let's write what we have. 2 delta y over t is equal to VF plus VI. Okay, so we were solving for final velocity, right? So we have one last step. we need to get rid of the initial velocity on this side. So this is a plus velocity, so what we have to do is subtract that initial velocity from both sides. So we're going to say minus vi. And then on this side, we have to do the same thing. You can either put minus vi here, or you put a negative vi and add it. Adding a negative is the same thing as subtracting a positive. Cancels them out over here. So now you have Vf is equal to Vi plus 2 times delta y over t. But let's rewrite that equation to look prettier. Put the variable we want on the left side. Final velocity is equal to, and let's just rewrite this so Vi is over here. 2 delta y over t minus Vi. 2 delta y minus Vi over t. So that's how to rearrange equations. Get used to it.